What unifies everything and everyone everywhere? This question has baffled physicists and scholars for centuries. Nobel Prize winner Albert Einstein came up with the most respected physics equations, but his dream of finding the unified solution eluded even him. Where should one look for the answer to this universal puzzle? To the past? The future? The ends of the cosmos or beyond? Or inward? Is the answer inside a particle? A proton? Does our consciousness affect the nature of reality? Maybe clues have been left for us throughout the centuries, encrypted in sacred icons and symbols. Who among us can unravel the mysteries? Einstein was a technical assistant at the patent office when in his spare time he cranked out some of the most remarkable theories. Theories that remain the crux of classical physics today. Einstein once said, "Any intelligent fool can make things bigger and more complex. It takes a touch of genius and a lot of courage to move in the opposite direction." You expect a physics mastermind to be holed up in a big stone building with ivy crawling up the walls, not on the ski slopes of British Columbia, or swimming with the dolphins off the big island of Hawaii. Scuba diving and exploring the Bimini Wall near the Bahamas, or scaling the rest of the physical world, literally and mathematically. Nassim Haramein was born in Geneva, Switzerland in 1962. Like many other savants, this imaginative child frustrated teachers to the point he was ostracized. Few around him knew of the equations, mathematical quandaries, and probabilities that consumed his mind. As a young adult, Haramein spent months living alone in a van in California, tackling these nagging concepts until he met believers who supported his efforts.
This is our entrance to the laboratory.
Haramein struggled for the next 25 years working alone and with world-renowned physicist Elizabeth Rauscher, testing and finally potentially solving Einstein's dream. This lifetime of decoding started in 1972 when a teacher sparked Haramein's faithful inner journey.
This all kind of started when I was about 10 years old, and I got in my first geometry class. It was an exciting time because the teacher went to the blackboard and made a little dot and said, "Today we're going to learn about dimensions." When he said dimensions, I got all excited because I thought, oh, he's going to talk about all these worlds I live in my mind and all these other things I'm experiencing. I thought, wow, that's the first adult that's going to talk about that. And so I got really excited, and then I got really disappointed because after he put the little dot on the blackboard, he said, the dot is dimension 0 and it doesn't exist. And I thought, oh, I think I'm gonna fail this class because I could see a dot from all the way in the back of the class. So if I could see it, how is it that it didn't exist? Then he did something even more miraculous. He put a bunch of dots together to make a line, called it dimension 1, and said that didn't exist either because it still didn't have volume. Then he put 4 lines together, made a plane, called it dimension 2, said that's the dimension that our comic strip books live in, and he said that doesn't exist either because it still doesn't enclose volume, it's flat. The teacher then did something remarkable. He took 6 of these non-existing planes, put them together into a cube, and said, now the planes enclose volume. This is dimension 3, and that's the one you exist in. And I thought, wait, how's that possible? I don't care if you have 1,000,000 non-existing planes. If you put them together, you still don't have existence. This didn't work for me. I thought, if the dot doesn't exist, the line doesn't exist, the plane doesn't exist, you don't have existence. Eventually I found out many other people found the same problem when they were young and were taught these axioms. One of them was a famous geometrist, Buckminster Fuller. Well, Turns out that this fundamental axioms about geometry is some of what most of our math and physics is based on. Our physics and advanced physics, Einstein field equations, quantum theory, all this is based on flat space. And if these axioms, if this fundamental concept is not correct, then most likely what we're going to end up with when we run all these physics and all these mathematics to understand our world is going to be a little tweak. It's not going to be quite correct. So I didn't know all this at the time, at the age of 10, but certainly I wanted to understand it. I wanted to find a new solution. I had a long bus ride going home, and I thought, I got to figure this out. I was in the bus, and I was thinking, I'm not going to get out of the bus until I got this figured. I didn't know that many philosophers and scientists had grappled with this problem. I closed my eyes in the bus, and in my mind's eye, I visualized myself seeing the bus from above. And I rose further and further, and as I did, the bus started to look like a dot. And then eventually, I rose further, and the country I was in started to look like a dot. And I rose further, and I saw the Earth starting to look like a dot. And I rose further, and I saw the solar systems looking like a dot. And I rose further, and I saw the galaxy looking like a dot. And I thought, oh my God, it's dots all the way up. And then I flew back into the galaxy, flew back into the Earth, and found the bus I was in, and opened my eyes and looked at my hand, and I thought, wow, I wonder what's in my hand. And I closed my eyes again, and I flew into my hand, and I thought, wow, it's made out of millions of dots, cells. And then I flew onto the surface of one of those cells, and I looked around, and it was made out of millions of smaller dots that looked like stars in the sky. And I thought, whoa. And I flew into one of those dots and looked in the middle. Sure enough, there was another teeny-weeny dot in the middle of those atoms. And I thought, wow, it's dots all the way down. And a light went on, and I thought, oh, the way to solve the dimensional problem is to reverse the axiom completely and say the only thing that exists is the dot. Within the dot is infinite amount of division, infinite amount of information. And I thought, wow, everything is made out of dots, and the dots are arranged differently, and that makes up our whole world. I opened my eyes, and I looked at all the people in the bus, and I thought, wow, they're all made out of dots, and I could kind of see the infinite dots of their existence. I got really excited. But then I started to realize through a few other experiences that, wait a minute, if it's infinite divisions, if it's infinite, how is it that we get finite structure? How is it that we get a finite boundary? How is it that we have finite systems with like infinities?
Haramein didn't know it at the time, but he was grappling with one of the biggest chasms in current physics. Einstein's theory of general relativity covers the cosmic scales and the relationship between gravity, time, and space. It predicts continuum to an infinite point of singularity, or a black hole. Quantum theory covers the smallest units in the universe and predicts finite and linear boundaries. The two theories are at odds, but Haramein believes both viewpoints are interconnected because everything big is made up of something small.
In general, we could define our society in two ways. We've got people that have a tendency to be very spiritual, and these people tend to think in terms of infinities, that infinite potential and all this stuff. And on the other hand, we have scientific people that tend to think in finite systems, closed systems that have very defined boundaries. And the two don't necessarily agree. And I think that at this point, this has to come together. And in a very simple way, I'm going to show you geometrically that infinities and finite systems are actually complementary. If we take the boundary of a circle and we define that as our finite space. Now that circle could be a sphere. And we divide that circle so that a triangle is formed in it. An equilateral triangle in this case. Now the universe is polarized. Everything in the universe seems to spin, so spin produces polarity, so we would have a reverse triangle at the same time. As soon as we do this, now we've created a new boundary condition at the next fractal level down, the next iteration down. Now notice that these new boundaries all are centered around a very specific center. That is, each of the boundary defines a very specific structure in space-time, a very specific coordinate in space-time. And so each of the boundary could be defined as a very specific set of information. Now I can continue to divide the space to produce new boundary conditions. Now I've got another iteration down and another set of information. Now I can continue to do this and create new boundaries again. And at this point, you can imagine that if I give this to my computer, it could zoom in, bring it back up, continue to divide the space, zoom in, bring it back up, continue to divide the space, and it could do this to infinity. However, I would never, ever, ever, ever exceed that first boundary I've produced for myself. So here, I've embedded infinite amount of divisions, infinite amount of information within the confine of a finite space. So in very simple terms here, I've shown to you that infinities and finite structures are complementary. That within the confine of what appears to be a finite space can be embedded infinite amount of information. And if this is true, this simple concept could change all of our concepts of physics, including our concepts of our relationship to the universe. So why is that true? Think of yourself as made out of cells that are made out of atoms. Now there's about 100 trillion cells in your body and billions of atoms per cell. And imagine that all these cells and all these atoms can be further divided into subatomic particles that can be divided into subatomic particles and so on towards infinity. That would mean that you actually, even in your physical body, have a function of infinity. That is, you have an infinite nature within the confine of what you call the physical world. So you don't need to even have a spiritual concept of your infinite nature. It's actually the way you're made, if this is true.
This complementary fractal condition could change the fundamentals of physics. Quantum theorists adhere to a concept called the God particle. If we look hard enough, they believe, we'll discover the smallest division that the universe creates. Here's another way to approach it.
At first, when we had our first microscopes, when we saw cells, we thought, oh my God, those are so small, they gotta be the smallest thing the universe does. And then we found that those cells were made out of atoms. And the atoms are so small, we thought, oh, those are gotta be the God particle. Those are the smallest thing the universe does. And then we found that those atoms have nuclei in the middle, protons, neutrons, and those are teeny, weeny particles compared to the size of the atom. The universe goes all the way down to that size and then stops and says, okay, that's small enough, I'm not doing anything smaller. However, then we found quarks and so on. And at this point, we're building accelerators that are enormous, an extraordinary device that accelerates particles at faster and faster rates to get smaller and smaller particles, thinking every time that we're going to find this fundamental particle that can no longer be divided. However, every time some physicist somewhere write a new equation saying, oh, maybe there's another energy level, da-da-da-da-da, and then next thing you know, we're building a larger accelerator to try to find it. And now we're looking for things that are billions of times smaller than an atom. But based on this concept that we've just learned about, we would know that this can be done to infinity, that you can always get a smaller and smaller particle if you could get a larger and larger accelerator. So what is this really telling us about the universe? I think that a more worthy exploration would be to stop looking for a fundamental particle and start looking for a fundamental pattern of division. Because if we could find a pattern in which the universe divides, then we would have the key to creation. And that could be really useful. My first sponsors wanted me to spend a lot of time, interacting with other physicists to try to get some support from them and as well discuss ideas and see where my theory related to the mainstream and so on. And so eventually he dragged me to a bunch of different physics conferences, and I wasn't so excited because I already had a bunch of run-ins with the mainstream scientific community, and I was a little worried. But eventually, I got into this private conference at Georgia Tech, and we were discussing very advanced physics, string theory. There was equations everywhere, and so on. And I was kind of irritating people a little bit because I kept on asking fundamental questions. The only book I had brought was this book, Gravitation. Gravitation is the Bible of relativistic equations, and it's written by giants of physics, Wheeler, Thorne, and Mesner. And it has all the equations that describes relativistic equations and curvature of space and gravitation. And it's called Gravitation because it's pretty thick. So when you pick it up, you know everything you need to know about gravity. At one point I stopped the conference and I said, wait a minute, I got to understand something. I opened Gravitation to page 719 and I said, if I understand well, this is our current model of the universe. It looks like a balloon that's being inflated that has pennies glued to it. And the pennies are representative of galaxies. And as the balloon inflates, the pennies move away from each other, representing the expansion of our universe. And they're all looking at me, going, yes, this is the current model. These are fundamental principles. What I want to know, and I've looked in many, many different physics books. I read all these equations, worked out all this stuff. What I'm not understanding, and you gentlemen might be able to point this equation to me, I haven't found anywhere where it explains who's this guy. And the whole room became really quiet. I will always remember one of the students was drinking coffee, and he kind of coughed a little bit when I said that. He thought maybe I'd say the word God in the physics department. Look at it this way. When the balloon expands, the lungs contract. So for every action, there's an equal and opposite reaction. Some of the first laws of physics. In our current model, the universe is expanding, but nothing is contracting to make it expand. So how is it that the balloon can expand if you're not compressing air into it? For me, it was a crucial moment. It had come from earlier experiences when I was young, where I realized that, there's an external world to my experience, but as well is an internal world to my experience. And I thought maybe the boundary conditions of the division of the universe are the result of the relationship between the outside world and the inside world. and that the two are like colliding wave, like standing wave that produce boundaries. I was thinking, if I was to point at something that connected all things, what would that be? If I could choose just one thing that connects everything, what would that be? Eventually, I came to conclude the only thing that's everywhere, that connects all things, is space. Space is everywhere. Between galaxies, between stars, between planets, between cells, between atoms, and even the atomic structure is made out of 99.99999% space. So the reality we live in is mostly space. Everything you see, all the material world that you think is so solid, is actually mostly space. What you're experiencing as your reality, what you call the material world, is actually 0.0000001% of what's there. Yet we spend most of our time paying attention to that part and forget to look at the space. For me, earlier on, it was crucial that maybe it's the space we should be looking at. Maybe we should pay attention to the 99.9999999%. Maybe objects don't define the space, but space defines the objects. Well, if that was true, and if the vacuum, if the space was connecting all things, since all things radiate in the space, and if the space is the source of all things, then that space could not be empty. What we call the vacuum, what we call so-called empty space, could not be empty. It had to be full. And it had to be infinitely full. Very, very dense in any case.
Does current quantum field theory account for this density? Haramein turned again to the Book of Gravitation, where he was surprised to find supporting evidence. Quote, present-day quantum field theory gets rid by a renormalization process of an energy density in the vacuum that would formally be infinite if not removed by this renormalization.
So, in current quantum field theory, it is necessary for the vacuum to have a very, very high density level in order for us to be able to run our equation and account for everything that's going on at the atomic level. That was a confirmation point for what I was already thinking about, that the vacuum is not empty, that space is actually a fluctuation that may be actually the source of our reality. But what is renormalization? Well, there's two kinds of infinities in physics. There's an infinitely small number. In general, a theory that comes up with an infinitely small number, the number can be discarded. It's not very important because it's a very, very small number. However, there's another thing that creeps up in physics, and when it does, it's called nasty infinities. And that is an infinitely large number. When an equation gives you an infinitely large number, you can't just say, I'm going to ignore that. So what is done usually, other than being said that the theory may be breaking down at that level, is that that number is renormalized. So usually what's used is a fundamental constant to cut the number. In this case, what was used was the Planck's distance. The Planck's distance is supposedly the smallest thing the universe does. You could think of it in really simple terms as the time or the distance it takes a photon to go across itself. It's the smallest wavelength the universe is supposed to be able to do. Do I think that the Planck's distance is the smallest thing the universe does? No. I think that the Planck's distance is a boundary condition that is a fundamental boundary in relationship to our experience. But I think that there's further definition, there's further structure below the Planck's distance. In any case, using the Planck's distance, which is 1.616 multiplied by 10 to the minus 33, extremely small, billions of times smaller than an atom, they renormalized the vacuum. What they did is they took a centimeter cube of space and they said, how many of these Planck's distances can we fit in, can we squeeze in into a centimeter cube of space? And if we do that, we'll have a finite number for the density of the vacuum. Basically, how much fluctuation of Planck's distances is there in a centimeter cube of space? So they stacked little Planck's distances full into a centimeter cube of space. Each one have a very specific mass, 10 to the minus 5 grams, and they added all up to get a fundamental density. The result was still extremely large. The result is 10 to the 93 grams per centimeter cube. That is an enormous number. You might have noticed in your bank account, every time you add a zero, it makes a big change. Imagine that you have 50-some zeros and you keep adding. At 93 zeros, right, you've got the density of the vacuum. Well, to give you an idea of how dense is that, imagine that you took all of the stars we see in the universe. There's billions of galaxies, they have billions of stars in them. Some of the stars are even much larger than our sun. And we took them all and we squished them all into a centimeter cube of space with like this huge trash compactor or something. You still wouldn't have the energy density of the vacuum, because the universe is approximately 10 to the 55th gram. So 10 to the 55th gram squeezed into a centimeter cube of space is still some 39 orders of magnitude smaller than the structure of the vacuum, the density of the vacuum. So to think of empty space as empty is incorrect. Space is full. It's full of these fluctuations. It's full of this energy density that is actually, according to what I found, the source of all of reality. The negative space is what produces our material world. Based on this, I started to think about it in terms of division of this vacuum density. I started to think of our reality not as object in the space, but as division of the space. I started to think maybe we could start to find patterns in the division of the space. Elizabeth Rauscher and I published a paper, and this paper described a scaling law. The scaling law is simple. On one side, we have energy density, and on the other, we have a radius. So the graph represents energy in terms of hertz in one direction and the radius in the other. And we started to plot all of the objects we see in the universe. We started with the universe itself. We ran the equations and we took the data that's available to approximate the radius of our universe. And then we approximated its energy levels, and we plotted the first data point. When you look at our universe, its size, and the amount of material in it, you find that actually our universe obeys the condition of a black hole. Our universe is too dense for light to actually escape it. If we were to shine a laser in our universe right now, it would get bent a little bit by our local star, our sun. Then it would eventually get to another star and get bent a little bit more, and it would get to another star and get bent by that gravitational field and get bent by gravitational fields of galaxy and all this. And because there's so much mass, there's so much matter in our universe, in its radius, in a closed universe, actually light would not be able to escape it. It would come back onto itself. So in fact, our universe can be considered as a black hole. Technically, it obeys that condition. Did you know you live in a black hole universe?
The universe, with its black hole condition, was the first data point Haramein charted. He next added galactic centers and stars. They lined up in a linear progression with the universe, an amazing result. If the vacuum is the source of the division, then it divides in very specific relationships. The next step was to see if the pattern continued on the other end of the physics scale.
Now we went from stars all the way down to atoms, right across the quantum world, from relativistic equation to the quantum world, and we plotted the energy level of an atom and its radius. And sure enough, the data point lined up again. Now that's a huge jump. And then we went all the way down to the Planck's distance, singularity, and that lined up as well. All the way from universe, which is immense, to a teeny point, billions and billions and billions of times smaller than an atom. And all this, all the data points in between, lining up so very closely to a perfect linear progression. Remarkable. Showing that there is structure, that there is order, that the vacuum is dividing in very specific relationships. And when we start to look at the relationship between the divisions of the data points, we found that the relationships were very close to phi ratios. The phi ratio is found everywhere in nature. When you look at your hand, the end of your finger is 1.618, which is the phi ratio, smaller than the second part of your finger. And the second part is 1.618, smaller than the third part. And your hand relative to your forearm, your arms relative to your body, and so on. Those Fibonacci sequence or phi ratios are found everywhere in nature, in plants, in flowers, the branches of a tree, the roots of a tree, the nervous system of your body, all of the divisions that produces all of the arteries and the veins of your body, and so on. All phi ratios, all Fibonacci series.
The phi ratio is evident even beyond where our eyes can see. The most recent discovery confirmed that the phi ratio exists even at the atomic level. Researchers in Germany observed that a chain of atoms acts like a nanoscale musical instrument, whereby the phi ratio seems to be the preferred division of the musical notes.
So it was remarkable to find it on such a huge scale. It indicated that the scaling law was correct, that the structure is evident and it is present even on enormous scale. Where is the structure coming from? Most likely from the structure of the vacuum itself, the division of the vacuum. It was clear to me that the vacuum must have fundamental structure. There was another data point that was very interesting. When you take the biological resolution, the microtubules, which are small entities that makes up the structure of cells, they are much, much, much larger than atoms, but they oscillate at a very high rate, 10 to the 11 to 10 to the 14 hertz. So we plotted the microtubules on our scaling law, and sure enough, amazingly, it almost landed on the linear progression perfectly and divided the scale almost in the middle. between the extremely large and the extremely small. There was this biological entity that makes up the biological world, as if biology, as if your structure is the boundary condition that divides the extremely large to the extremely small. You are the event horizon. It started to make sense that all this organization would include the biological structure. Because when we see our biological world, when we see our environment, when we see our biosphere, it's highly organized, and these phi ratios are found everywhere. There was another data point that was interesting in the scaling law. The atomic level is in between the universal size and the Planck's distance. Now, as we saw, the universal size can be considered a black hole. It obeys the Schwarzschild condition. And the Planck's distance obeys the Schwarzschild condition. So having the atom right there on that linear progression started to indicate that the atom may be a black hole itself. As we saw earlier, the division of the space can be done to infinity. If an atom has subatomic particles that are made out of sub-subatomic particles that are made out of sub-sub-subatomic particles and so on to infinity, and each one has a mass, then there's infinite mass at the center of atoms, and to me, very early, I concluded they must be mini black holes. From this conclusion, I extrapolated that there must be a black hole at the center of all galaxies. I said that very early, almost 17 years ago. However, at the time, there was not much data about the center of galaxies, so many physicists thought this was improbable. Eventually, we got more and more data about the center of galaxies, and we found that there is a black hole at the center of what seems to be every galaxy we observe. So that confirmed that I was on the right track. But how is the atom a black hole? Is it possible? Is our current physics say that? No, it doesn't. So I had to start looking at how we wrote our physics for the atomic level, and how they could be written in a different way. Could we approach the atom as a mini black hole? Eventually, this is how I solved it. And it is the crux of the unification theory that I'm bringing forward. Because if we can describe the atom as a mini black hole, then we can describe the atomic world with Einstein field equations. So I looked at the atom in detail. What I did is I said, wait a minute. We have a density of the vacuum of 10 to the 93 grams per centimeter cube. Is that considered when we look at the atom? No, because in current physics, although that number is used all the time in quantum theory to make our equations work, it is assumed that the vacuum density does not have any physical meaning. We know for a fact now from experiments that actually the vacuum density can be measured in laboratory and has mechanical effects. So if it has mechanical effects, it obviously has meaning in our material world. I wondered how much of vacuum would be present inside the nuclei of an atom would that energy be enough to make the nuclei of an atom a black hole? So I looked at the proton, which is at the nuclei, and I started to extrapolate how much vacuum would the proton volume still contain, knowing that there's 10 to the 93 grams per centimeter cube in a centimeter cube of space. How much of that vacuum would still be present in the volume of a proton? I calculated the volume of a proton and found that there is still 10 to the 55th grams in a proton volume. 10 to the 55th grams of vacuum energy is still present in a proton volume. Where did we see that number? 10 to the 55th gram is the mass of the universe. There is the mass of the universe present in vacuum fluctuation, in vacuum density, in the volume of a proton, which is a very, very small entity. This confirms something fundamental to me. It confirmed that the vacuum is truly the thing that connects all things. It showed that everything is entangled and everything is one, and it showed it mathematically. It's one thing to say everything's one, which is some things you find people saying in spiritual worlds. However, this actually proves it. So is 10 to the 55th grams enough to make the proton a black hole? Oh, absolutely. Since 10 to the 55th grams is enough to make the whole universe a black hole, when that's present in a small volume of a proton, it's more than enough. I calculated how much of that is actually necessary to make the proton a black hole. And I found that it's only necessary for 10 to the minus 39%, a very small number, teeny, teeny number, a decimal with 39 zeros, right, to make the proton a black hole. A very small amount of the vacuum can become coherent and be converted to mass to make the proton a black hole. It was very amazing because when we did this, at the same time, we calculated many things for such a black hole proton. And it turns out that it gives us all the correct answers to describe the atomic level. And from the experiments that are done in laboratory and the results we get in laboratory, all the correct answers were coming out. But our proton was much heavier than the standard proton. So which one is right? We were getting the right answers from a completely different approach than quantum theory. In fact, we solved all of that using classical mechanics or semi-classical. So we wrote another scaling law to see if our proton mass was in the right ballpark in our universe. We plotted all the data points again, but in this case, we used mass against radius. We started with universe, and we went all the way down to the Planck's mass. And we plotted many, many different data points in between. We used galaxies, quasars, even our sun. We put even the Earth in there. We used pulsars. And then we plotted our Schwarzschild proton, our black hole proton, and it fell almost perfectly on the linear progression. Amazing, remarkable. However, the standard proton with a mass of 10 to the minus 24 didn't even come close, completely off in left field. That confirmed to us that our black hole proton was actually much more aligned with the fundamental principles of our universe. Our proton mass produced a large gravitational field. And when we looked at the gravitational field, we found that it was actually exactly the amount of attraction that we needed between protons to overcome the Coulomb force. The Coulomb force is the force that pushes protons apart. It's an electrostatic charge, just like two magnets that are approached together tend to want to repel if they're the same polarity. Well, the protons are squished with the same polarity into a very small nuclei, and the Coulomb force would be very, very strong. Well, when we calculated for two little black hole proton, we found that the gravitational force was exactly what it needed to be to squish those protons together against the Coulomb repulsion. And this way, we could eliminate one of the fundamental force of quantum theory, called the strong force. And by doing so, we united the quantum world with relativistic equation, with the equations that describes black holes, galaxies, planets, stars, and now the atomic level. What is dividing the vacuum? How does it divide? What is its structure? How does it become coherent? Is there a fundamental geometry that defines it all?
While searching for this fundamental structure of the vacuum in physics and mathematical equations, Haramein discovered geometrical knowledge in other curious places, ancient texts and traditions. Unknown to him at the time, many famous physicists found supporting data from historical manuscripts, including the founder of modern physical science, Isaac Newton. And German astronomer Johannes Kepler used geometrical concepts often found in ancient knowledge to elaborate the mechanics of our solar system.
I looked at various traditions around the world, the Mayan, the Incas, the Egyptian, and I found that many of them, including the Chinese, the Japanese, and so on, had made very geometric structures all around the world. One of them is Teotihuacan, amazing complex north of Mexico City that included the Sun Pyramid, the Moon Pyramid, the Way of the Dead, and many complex structures all around it. I found that a survey had been done by an American engineer called Hugh Holliston Jr. He had spent 20 years mapping out the relationship of all these buildings to each other. And as he did, he found that there was some fundamental mathematical constant that were involved. I had already come up with the concept that a tetrahedron would be involved in the structure of the vacuum, since it's the most stable of the Platonic solids. But what Hugh Holliston Jr. found is that not only did this ancient complex portray the movement of the planets and their orbits relative to our sun, but as well had a fundamental mathematical constant that related a tetrahedron to a sphere. Why would the ancient Mayans represent this very specific relationship between a tetrahedron and a sphere? I thought maybe, just maybe, they were trying to deliver a message throughout the ages about the importance of that relationship. The structure of the vacuum as a tetrahedral structure and the sphere as the boundary condition that divided the space. I looked into it deeper and I found that not only these mathematics were portrayed in the relationship of the buildings in that complex, but that the complex itself, positioned on the surface of the Earth, mapped the relationship of a tetrahedron in a sphere. I thought it was very significant, and it wasn't a coincidence.
Energy events across the solar system frequently happen along or near the 19.47 meridian, which is the base of the inverted tetrahedron in the Earth's sphere. The pyramid system at Teotihuacan in Mexico lies on this meridian, as does one of the most active volcanoes on Earth. Kilauea in Hawaii has been erupting continuously for the last 19 years and shows no sign of stopping. The largest volcano in our solar system is located on Mars, and it too is located in this vicinity. The well-documented red spot on Jupiter, a large vortex-like storm larger than the Earth, is also stabilized near this critical 19.47 latitude.
As I studied more geometry, I came across Buckminster Fuller, that had done much work in describing complex geometry relative to our reality. And Buckminster Fuller came to conclude that the fundamental blueprint of the universe was what he called an isotropic vector metric, or a four-frequency isotropic vector metric. There is 20 tetrahedron in the four-frequency isotropic vector metric. 10 on the bottom, 6 in the middle, 3 on the third floor, and 1 on top. And it makes a larger tetrahedron when it's put together. What I was interested in was the negative space. I wanted to know what's in between the tetrahedrons. When you put tetrahedrons edge to edge or edge bounded, you get octahedrons in between. Octahedrons are pyramids base to base. Emphasis on the word pyramid. When I looked at the negative space, I found that there was another set of tetrahedron that was like the negative space. And those tetrahedrons in the middle were reversed and rotated 180 degrees. I didn't know what they were doing there. It was like there was asymmetry in the isotropic vector metric. With the word isotropic, you would expect no asymmetry. I was looking for perfect equilibrium, so this was not satisfactory to me. I had to figure out what these other tetrahedrons were doing there. I realized that one isotropic vector metric could not be alone. It had to be polarized. And so I stacked two on top of each other. However, now I had another problem. The two on top of each other didn't make a sphere, it made an egg. And the concept I had developed was that the tetrahedrons produce the sphere that divides the boundary from infinitely large to infinitely small. So I didn't know what to do. It was like an egg and a chicken problem. I thought about it for weeks, eventually realizing that I had to push one into the other. I didn't want to distort the geometry of the tetrahedron, but when I actually got the two so that they would produce a perfect sphere, I realized what these other negative space were for. In fact, the one metric was awaiting its better half. It was not actually complete until the reverse metric was inserted into it. And when it was, all of a sudden, these other spaces were there to accept the reverse tetrahedron. Like one tetrahedron male metric was waiting for its counterpart. It was remarkable. It was the polarities coming together to produce the perfect sphere. And I looked at what geometry was produced in the middle. No tetrahedrons were distorted. And the resulting geometry in the middle is a cube octahedron. Why is a cube octahedron important? Because Buckminster Fuller coined it the vector equilibrium. It's the only geometry in perfect equilibrium in all vectorial possibility. And that was exactly what I was looking for. The polarities coming together to produce singularity, to produce perfect equilibrium at its center. I thought, this must be the geometry of the vacuum.
Buckminster Fuller reasoned that if the force of a vector is its length, and two vectors are driven against each other in opposite directions, you will get equilibrium. But it will be unstable equilibrium because any other force in any other direction can break the balance. You could add 2 more vectors at 90 degrees from the initial point, but in that case, the edge vectors that contain the geometry would be longer than the vectors to the center, creating instability. Fuller realized that the edge vectors and the vectors to the center have to be the same distance. This creates a hexagon, or in 3 dimension, a cuboctahedron, or vector equilibrium. From this, Haramein concluded that this structure must be the geometry of the vacuum, since in perfect equilibrium, all the forces would cancel out and appear to us to be empty space.
However, I had found yet another issue. When I looked at the geometry carefully, the vector equilibrium in the middle was completely covered with tetrahedrons, but the edges of the metric still had open faces. I was looking for perfect symmetry. So I had to continue adding tetrahedrons to cover those faces. I had already 2 isotropic vector metric of 20 tetrahedron each. That made it 40. I had to add another 24 tetrahedron to cover all of the faces that were open faces on the edge of the metric. 20 plus 20 is 40, plus 24 brought me to 64 tetrahedron. This turned out to be a very significant number. Not only a number found in many ancient traditions, but a number that is found in many natural processes. The 64 tetrahedron grid kind of bloomed in to a whole new understanding of the structure of the vacuum. It was exactly what I needed. It had an equilibrium at the center that was actually surrounded by another equilibrium. And you could visualize this structure growing in perfect fractal octaves from infinitely big to infinitely small. I had not only my polarities producing the equilibrium and singularity, but as it did, it produced fractal structures that could be scaled from infinitely big to infinitely small. I felt I had found something very profound. It was a true 3-dimensional fractal structure, and it grew in perfect octaves. I could see that this metric could actually be built in a completely different way as well. It could be built out of 8 star tetrahedron, each made out of 8 tetrahedron each. The 8 star tetrahedron coming together produce the 64 tetrahedron grid. 8 star tetrahedron are built by 8 tetrahedron, have their tetrahedron pointing out, radiating out. And when they come together, they produce the vector equilibrium in the middle, which is 8 tetrahedron pointing in. So I had now both of the side of the event horizon that produced the boundary condition. The radiative side and the contractive side of the event horizon. I thought, this is it. I found it. And I got very, very excited. I thought, this has all of the elements necessary for me to be able to map out and describe the structure of the vacuum. The key to the knowledge necessary to understand creation.
Now, with the structure of the vacuum realized, the next step was resolving how it moves. This required updating the theories that preceded Haramein. When Einstein wrote general relativity, he described the structure of space-time as curving to produce a gravitational field. This was a change from Newton, who believed gravity was a force generated by the object itself.
Imagine a trampoline with a mass on it, like a big ball, and the trampoline is curved by that big ball. That trampoline surface has elasticity. And then imagine that another ball is put on the trampoline, that other ball would appear to be attracted to that first one due to the curvature of the surface of the trampoline. When Einstein wrote these equations, he didn't solve them. He just wrote the concept. He wrote the equation necessary to describe the concept. But the complexity of finding a solution was beyond what he wanted to do at the time. So he published general relativity, and by an amazing set of circumstances, a gentleman called Karl Schwarzschild, a German physicist, found Einstein's paper. And he saw these equations and he thought, hey, I can solve this. And Karl Schwarzschild went on to finding the first solution to Einstein field equations. And that solution remains to this day as the Schwarzschild solution.
Unfortunately, months after Karl Schwarzschild solved Einstein's field equations, he died of an autoimmune disease, leaving the solution without any mention about the spin of the black hole. Spin and charge were introduced in the 1960s in what is commonly known as the Kerr-Newman solution. However, this theory did not account for the gyroscopic effect that Haramein knew needed to be accounted for.
I had realized that there's something strange about the way our physics has been addressing spin. We might have missed something in the way we were describing spin in our current physics. This led again to another paper written with Dr. Elizabeth Rauscher. This paper was entitled The Origin of Spin. It described a new way to define the structure of space-time. If the gyroscopic effects are added, that means that the trampoline is not curving smoothly, but it is spinning as it curves. That space-time has a fundamental spin. Just like water going down the drain doesn't go down the drain straight, it spins as it goes down the drain. And that produces a fundamental torque. So torque and Coriolis effect had to be put back into Einstein field equations. Dr. Rauscher and I worked diligently for over 1.5 years to make that happen. It gives a different picture of the structure of a black hole. Instead of a spherical smooth surface, Coriolis effect were involved, and the surface was not a perfect sphere, but a torus. A torus is like a donut. It has a hole in the middle. And the result then was a dual torus structure. Because of Coriolis effect, one donut would be going in one direction and another donut would be going in the opposite direction. For every spin, there's a counterspin. Just like the weather patterns that we find on our planet, where hurricanes spin in one direction on the north hemisphere and spin in the other direction in the south hemisphere, and they meet at the equator, but go back to the poles and meet at the equator again. This animation shows the movement of a particle over the metrical space of the structure of space-time imbued with torque and Coriolis effect. All of a sudden, you can see that the information can move to the poles in towards the singularity and back out at the equator and back into the pole, and thus you get this feedback structure that could be found at the atomic level. For instance, this could be an electron and a positron, or at the stellar level where we see the plasma dynamics around the sun that produces the same dual torus dynamic, or at the galactic level. What's in the middle of a torus? What's in the middle of a donut? The hole, right, is space, the vacuum. And this is why the vacuum connects all things, because the vacuum divides not with the complete boundary of a sphere, but with a torus in which the vacuum is at the center of every object, where you'd expect singularity, infinite density of a black hole, but instead it's the vacuum which is infinitely dense, and that connects all things. It explained many different things, including the way magnetic fields are produced and where the origin of spin was. Not only is spin inherent to the structure of space itself, but it is prevalent at all levels if the structure of the vacuum acts like a fluid, acts like water going down the drain. We know that the electron and the positron exchange and disappear and reappear and disappear and reappear. It seems to exchange across the vacuum. That is, the vacuum fluctuates, produces an electron and fluctuates, and then the electron disappears. The electron carries the information from the material world to the vacuum, informs the vacuum, and then the vacuum informs back the material world when the electron comes back out. And so we actually are constantly appearing and disappearing at a very rapid rate, at the speed of light. Did you know that half the time you're the vacuum? Who are you when you're the vacuum? And what are you saying to the rest of the universe when you're informing the vacuum? From this model of the double torus, we started to have an understanding of why consciousness emerges. Consciousness demands feedback. In order for you to be self-aware, you must know that you exist. Thus, it demands feedback. This structure of the double torus allows for the feedback between what's coming from the outside that's going back to the inside, informing the vacuum, coming back out the outside, and as it comes back out the outside, the vacuum informs us of the result of the information present in the vacuum. It is an exchange between your internal understanding and experience of the universe and the relationship of all the understandings put together in the vacuums affecting yours. So you're not creating your reality, you are co-creating your reality with everybody else.
But how does the double torus geometry relate to the tetrahedral structure of the vacuum? For Haramein, it all came together when he visualized two isotropic vectrometrics surrounded by a toroidal field. Each represents a polarity of the Coriolis effect. As the two come together to form the vector equilibrium, the double torus structure is generated. When all the components are producing equilibrium at the center, the result is singularity, and all of creation emerges from it.
When we solved this new solution to Einstein field equation with torque and Coriolis effect, we found that we could mathematically show a fundamental relationship between the cube octahedron and the double torus as well. And when we did that, it produces all the information we need to generate a unified field theory. So this relationship between the structure of the vacuum and the dynamical division of the vacuum based on spin, torque, Coriolis effect produce a complete understanding of the geometry of space and the reality that emerges from space. Look at this galaxy, for instance. You can see that stars are emerging from the central bulge, in which an enormous black hole lives. We know now that there's a black hole at the center of all the galaxies. Not only that, this theory as well predicted that galaxies are the result of black holes. not the cause. That is, that the material reality we see emerging is actually being produced by the central heart of the galaxy, the black hole. Particles are being created in a continuous creation process, not just one Big Bang, but continuous creation at all levels of singularities along the scaling of our universe. When we look at the stars in a galaxy, they emerge from the central black hole and move in spiral path away from it towards the edge. At the edge, they enter into the galactic halo, which is the edge of the double torus, and then they fall back in at the top, just like water going down the drain. From recent data, not only do we find that black holes are at the center of all galaxies, but it seemed that black holes were there prior to galaxies. This is exactly what this theory would predict. Black holes are actually a fundamental pattern of the vacuum itself, and that produces matter and then eventually becomes visible to us as a galaxy, a star, a planet, an atom, a subatomic particle. This view then changes our concepts of black holes. Black holes should no longer be written black holes H-O-L-E, but holes W-H-O-L-E. They're no longer just absorbing information, but they radiate information as well. They're black-white holes. If you're on the inside of the black hole, like when you're inside our universe, it appears black. And if you're on the outside of the event horizon, they appear white, very bright. They radiate information, just like stars in our universe. All this relates nicely to many concepts that are found in ancient civilization. Many concepts that talk about the center of all things having God in it. The Buddha is at the center of all things. That the kingdom of heaven is within our center. Many tradition talks about us turning our senses inwards and going towards the center of our existence, to link with the whole universe from the center of our experience. We find this said in many different ways from many masters all around the world in ancient traditions. And in these same ancient traditions, we find very interesting buildings. For instance, take the pyramid at Giza. The Grand Pyramid at Giza is a remarkable building. It's made out of approximately 2,300,000 stones. It stands at 481 feet of altitude. After placing 2,300,000 stones, the apex of the Grand Pyramid at Giza is a quarter of an inch off center off the base of a 13-acre surface. Is that possible with the means that the Egyptian had 5,000 years ago? Or is it even possible with the means of construction and engineering we have today? Absolutely not. If you calculate how precisely each block had to be placed from the ground up, from the base up, to achieve this level of accuracy at the apex of the pyramid, it exceeds our accuracy with the best tool we have in our modern society today. So can that really have been made by a bunch of farmers and slaves 5,000 years ago, pulling on vine ropes with logs and so on? When we study buildings all around the world, we find very interesting things. Many pyramid sites around the world seem to represent a very specific constellation in our sky. That constellation is the Orion constellation.
This discovery was made only recently by Egyptian-born engineer Robert Bouval and writer-explorer Graham Hancock. If you view the Pyramid Giza and her two companion pyramids from the sky at night, the three axes line up very closely with the belt in Orion's constellation. Hancock and Bouval discovered that the Orion map also lines up in the same fashion with the pyramids at Teotihuacan, Mexico. The sun, the moon, and a smaller pyramid emulate this connection between stars and structures. This mystery continues across the globe. In China, where three pyramids close to the same size as Giza and Teotihuacan are located, it is unlikely that these alignments are coincidental. Many of these structures also have another commonality. The stones are enormous and include unusual precision carvings between the blocks as well as on them.
In this case, we find a very important symbol. The symbol is known as the flower of life. What's intriguing about this symbol is that it's not etched or carved into the rock, but it seemed to be laser burned into the atomic structure of the stone with an instrument that is not easily reproducible even with our technology today. When we look at this symbol and we extrapolate it to 3 dimensions, it looks like bubbles all agglomerated together, and it defines the position and the geometry of a 64 tetrahedral grid. Were they trying to tell us something significant about the structure of space in such a way that it could not be erased throughout ages of erosion? Were they trying to tell us something about the technology that was used to move these large rocks along long distances? Well, when we look in ancient Egypt, nowhere do we find an hieroglyphs or a series of hieroglyphs or text that tells us how they built the pyramid, how they moved the stone, how they got the accuracy necessary to do such a job. Everywhere in those texts, they tells us about sun gods, about these beings that seem to have come from very far away in our universe, and that brought information with them, knowledge such as engineering and writing and so on, that they educated the people of the earth with. Very advanced people. Maybe advanced people that were interacting with humans in prehistory, in time prior to our written history. This type of knowledge is found across many different countries, across many cultures. For instance, in China, where pyramids are found. China has symbols associated with their knowledge base, famous symbols. For instance, the yin and yang. The yin-yang symbol is very similar to the double torus structure viewed from above. Associated with this symbol is a set of mathematics, a set of symbols called the I Ching. The I Ching is made of 64 symbols. And each symbol is made out of 6 sticks. 6 full sticks or 6 broken sticks. 6 sticks put together in 3 space can only produce a tetrahedron. And when a star tetrahedron is generated, you will be required to break the sticks of the reverse tetrahedron to put it through the other. So by following the I Ching, we can actually rebuild the whole 64 tetrahedron grid. And that, associated with the yin and yang, produces the double torus and the structure of the vacuum. All the information necessary to describe this profound understanding of creation and the structure of the vacuum producing it. Now, when you look in China, you find as well the Forbidden City. The Forbidden City is guarded by the Fu dogs. The Fu dogs are the analog of the Sphinx in Egypt. They are considered the guardians, the guardian of knowledge. And they guard the knowledge by keeping it under their paw. When we look under the paw of the Fu dog, what do we find? Again, the same fundamental geometry of these intersecting spheres, in this case, in complete 3D structure that embeds the tetrahedral array of the vacuum. It's found in the Hebrew tradition, where the Hebrew God is typically represented as a tetrahedron sitting on a throne, and is not typically represented in ancient Hebrew tradition as an old man with a beard. When we look deeper into the Hebrew tradition and the Old Testament, it seems that it refers to a very specific object that had all sorts of properties as the power of God, the Ark of the Covenant of God. It is described as a very powerful object. Maybe some of these advanced technologies that were given to us by the sun gods remained in our culture. The Ark of the Covenant was described as this very bright object, this object that had a lot of radiation coming out of it. And it is typically represented as producing a large vortex or cloud above it. It's described in rabbinic tradition as an object that could lift itself and that could lift its carriers with it. Those would be evidence of gravitational effects. When we look at the word God in the Old Testament, actually, we find that it's a translation of a Greek word called the tetragrammaton. The tetragrammaton is typically represented as a triangle with the letters of God in it in the Kabbalistic traditions. Tetra can stand for tetrahedron. It as well is the Greek word for 4. Grammaton, however, has always been interpreted as grammar for the 4 letters of God, Yahweh. The root word of the word grammaton can be as well grams or gravity and refers to the weight of an object. So now we have a word for the word God that includes the tetra and gravity. Maybe there's a double meaning to the word God in the Bible. Now, with these Kabbalistic tradition comes a very important geometry. It is said that if this geometry is decoded, the understanding of the fundamental nature of the universe can be achieved. It is the Kabbalistic tree. It is akin to the tree of knowledge. It's thought to be the fundamental principle of creation. I looked at it in details. It spent many months trying to decode it. At one time, I realized that the bottom part of the Kabbalistic tree is a tetrahedron, and that the top part is an octahedron. However, I had this box in between with an X in it that I wasn't sure where it fitted. I eventually came to understand that I could slide the bottom part into the top part, and as soon as I did so, it became a three-dimensional object, giving me all the vortices to produce the star tetrahedron. Now further, the Kabbalistic tradition says there's not just one tree, but there's four, and that there's a principle of mirroring of the trees. If there's four and they're mirrored, that means altogether there's 8. And it says that they all attach at the root. If I attach 8 Kabbalistic tree together and decode them in each one into star tetrahedrons, then I have a 64 tetrahedron grid, and the Kabbalistic tree has been decoded. How do I know that it's been decoded? Because I can actually take the two-dimensional image of the Kabbalistic tree and plaster it back onto the 64 tetrahedron grid. This kind of loop in the code is actually described in the Kabbalistic tradition, where it says that the root is attached, and then the crown is attached, and then the root is attached again. The really interesting thing about these Kabbalistic trees coming together is that when you decode them, it's like they're being compressed into the center, and they become the star tetrahedron. So you actually have the sense of the compressive, contractive part of the vacuum structure. They're collapsing together, producing the star tetrahedrons and the 64 tetrahedron grid of the vacuum. When they are put together, the root of the Kabbalistic tree becomes the singularity.
The Mayans, the Egyptians, Chinese, Hebrew, and many others. Were these ancient civilizations from all different points across the globe leaving us detailed information about the structure of the vacuum? And even the fundamental physics of creation? According to Haramein, the structure of the vacuum and the fluctuations of energy in it are at the foundation of all our reality, and even the consciousness that animates it. We are in a relationship with the universe at all times, exchanging information on all scales. Has the time come when we can finally wake and acknowledge this powerful connection and even harmonize with it?
I think we are standing at the brinks of this transition. One of the biggest transitions a society can ever go through. A transition from a society that believes that there is limited amount of goods, that there is limited amount of space, and that wars for it, to a society that realizes that they are bathing in an infinite amount of energy available to them anywhere in the universe, and that that energy is the source of all creation. A society that understands how this fluctuation of energy function, how it structures, how it produces our material world, and hooks into it, taps into it, and align its technology to it in a harmonious way to transform the way they think of energy and transportation, and actually ascend from the surface of their planet. A society that has the capacity to move through their solar system in an easy way, and to move through even the galaxy, or even from galactic structures to other galactic structures, or even from universes to other universes. Such a society does not think of the universe as limited. A society such as this one, I believe, is the opportunity that is being offered to us at this time. This is the ride we're on. And I invite you to be a full participant.